Hi all, welcome back. In today's video, I will explain you few interesting SystemVerilog constraint question. And these are the most frequently asked interview question. Okay, so let me start with a very basic question. So the question is, write a SV constraint for even number generation between 0 to 100. Okay, so interviewer may ask you any range. So for simplicity, here I have used range 0 to 100. Okay, so for this, if we use a modulo operator, we can generate an even as well as odd number. Remember, there could be multiple ways. Okay, I will explain you two different ways for generating an even number as well as for odd numbers. Okay. So for this, first we have to define a class. A name can be, you can define any name, class, end class, and here I am defining one class property called a, which is of int type, and of course I have to define it as a rand, so that if in future if we are using this randomize method, this particular property will randomize. Randomize means it will generate a random number, and we are using a constraint over here to restrict this random number to generate an even numbers. So first we, as the range is between from 0 to 100, we have to write an inside construct which says that a inside within curly braces and the square bracket 0 to 100, so that the numbers of this int variable will be from 0 to 100. Okay, in between 0 to 100. Then we are using this modulo operator. What we are saying, a modulus of 2 is equal to 0, which means that we are dividing the a and the remainder is 0. Okay, then in the post randomize method, just we are printing the values of this a variable. Okay, so I hope you remember this post randomize method will execute after the randomization is called. Okay, then inside a module definition, module end module, I'm defining the instance of this class ABC like h1. Class name is ABC and h1 is the instance for that. And within initial begin block, I'm allocating a memory for this h1 instance using new construct. Then I'm using a repeat block to generate this 20 random values. So repeat 20, and I'm using a randomize method to generate a random values. Okay, so let me run this code. So what we are expecting, this particular code should generate an even numbers. Okay, 20 even numbers in the range of 0 to 100. Okay, so if you analyze the code over here, you will find all are the even numbers in this array. Okay, in this variable int a. Now analyze this 86, 38, 0, 34, 36 and so on. So all these are nothing but the even numbers. Okay, very simple. Now let me show you another way for generating the even numbers. Okay, so another way is like if the entire code will be same. Okay, the class definition, the module definition will be same, just in the constraint we are saying a is equal to within parenthesis a by 2 into 2. So this will also for sure generate an even numbers. Okay, this inside line is also same and entire code is same, just I'm changing this particular line. Okay, and in the post randomization we are printing the values. We are using repeat block 20 times to generate this 20 random numbers. So if you run this code, this a particular code of the constraint will also generate the 20 even numbers. Okay, so as you analyze on the console, you will find 86, 38, 0, 34, 86 and so on. So these all are like the even numbers. Okay, now let me show you the code, the constraint code to generate an odd numbers. Okay, so for odd number, just we have to use not operator, okay, with this modulus operator. So if you see over here, entire code is same, just inside a constraint. What I'm saying, I'm just changing the name of the constraint. You can take any name, okay, it's not mandatory to take the odd number, you can take any name. Now inside this constraint, what I'm saying, a inside of 0 to 100, so you can take any range, okay, and then we are saying a modulus of 2 is not equal to 0. This for sure will generate the odd number, and the entire code will be same, like module definition and all. So if you run this code, you will analyze in the console, it will generate an odd numbers. Okay, so let me show you the console output. So here you can analyze 87, 39, 1, 35, 55 and all. Okay, you can analyze later. All these are the odd numbers. Okay, similar to this method, now let me show you another method to generate an odd number. So this below method is also same as we used for the even number, like what we said over there, like a is equal to a by 2 into 2, right? Now in addition to this, just we are adding a 1 into this, so this will also generate an odd number. Okay, so the entire code is same, like class definition, like the constraint, inside a constraint we are using this inside is the same, and just we are changing this line, and the remaining code will be same. So I'm not explaining the code, as already I have explained. So if you run this particular code, it will also generate an odd numbers, 20 odd numbers, as we are using 20 in the repeat loop. Okay, so if you analyze the console output here, like 87, 39, 1, 35, 37, 99 and so on. Okay, so later you can analyze. I'll put a link of this code in the description. You can later analyze and play around with this code. Now let me explain you another interesting question. So question is, write a constraint for generation of a number for multiple of 4, which means that if we have to write a constraint, it will generate a number which should be multiple of 4. So the definition of a multiple of 4 is very simple, like if a number can be divided by 4 with no remainder. Okay, so this is what a multiple of a 4. Now if you see this code, in the class definition, I'm writing a variable called bit pi down to 0, a variable, okay, a class property. So 2 raised to power 6 is nothing but 64. Then inside a constraint definition, I'm writing a name like multiple of 4, and just I'm using a modular operator 4 is equal to 0. So this will divide the a with 4 and the remainder will be 0. So this is what nothing but a multiple of 4. Inside a post randomization, I'm just printing the value of a, and this is what the module definition, just I'm using the repeat loop of 20 to generate 20 random values. And if you run this particular code, you will find that the numbers are of divide by 4. What one error? Okay, so let's see this error. Okay, so if you analyze this output, okay, we'll find the numbers like divide by 4, 52, 24, 4, 8, 16 and all are nothing but a divide by 4. Later you can analyze them. So the simple logic, like a modulo of 4 equal to 0. This is what a simple a number which is a multiple of 4. Okay, now let me show you another question. Before that, the assignment for you guys is to write a constraint. which generate a number which is of multiple of 5. Okay, a simple one, right? And you can write a logic for that, which is also very simple. Okay, now another interesting question is that write a constraint for this pattern generation, like 0 1 0 1 0 1 0 1. Okay, so this is a very simple if we use an index. So let me show you. Okay, these total are 10, right? 1 2 3 4 5 and 10. Okay, so the index for them is like this 0. For this 0 is like index is 0, then for this 1 is index is 1, for this 0 is 2, then for this 1 is 3, and so on. So this is what the index for this particular pattern. Okay, now for this simply what we will do, we'll take a dynamic array. Okay, so as the pattern 0 1 0 1 is total size is 10, what we'll do, we'll define a dynamic array called a, that is of in type, and we'll define it as a rand, and inside a constraint we'll say that the size of this dynamic array is 10. Why? Because we want this 0 1 0 1 pattern 10 elements. So we'll say we are saying here the size of the dynamic array is 10, meaning from 0 to 9, a of 0 to a of 9. Now inside a for each loop, which is an interesting one. Okay, with for each we can write a many constraint. Okay, so what this for each is doing, for each in the parenthesis a of I, it means that this particular loop will iterates over each element of the array using this index I. Each element means from 0 to 9, a of 0 to a of 9, and we are saying if I modulus of 2 equal to 0, which means the even indices, meaning even means this 0, 10 2, then 4, then 6, and then 8. For this even indices we are saying the value of a is 0. Okay, for this even indices we are saying the value of a must be 0, else the value of a is equal to 1. Okay, for odd indices. Okay, very simple. Now inside a post randomization, just I'm using another for each loop to print the value of this a. Okay, using $display. The module definition is very simple. Inside the initial begin block, as of now I'm not using a repeat block, just I'm declaring the instance of the class and allocating a memory and using a randomized method. Okay, so if you run this particular code, you will see at even element we want it should be 0. Okay, this, okay, error was there. So what we want at even indices, the value of a must be 0. Okay, and for odd indices the value of a must be 1. So as you can analyze here, 0 2 4 6 8 are the even indices. For that the value of a is 0. Okay, and for odd indices you can see the value of a is 1. Okay, very simple. Now another question comes, like if we want at even indices the value of a to be 0, and for odd indices like 1 3 5 7 and 9, it should increment like 0, like 1 2 3 4 5 kind of thing. Here you can see, so the constraint is like 0 1 0 2 0 3 0 4 0 5. So it is also very simple. Just what we have to use over here is, let me show you the code. The logic for even indices is same. There's nothing change which is same compared to the above example. Just for odd indices, which is nothing but 1 3 5 7 9, what we are saying that a of I is equal to I plus 1 by 2. Okay, so I plus 1 is nothing but, let's say for example, if it is the odd indices, okay, meaning 1, so 1 a of 1 is equal to 1 plus 1 by 2. Okay, so 2 by 2 kind of thing. Okay, so let me show you this table over here. So index is, let's say 1, which is nothing but the odd index. Okay, and 1 plus 1 by 2 meaning 2 by 2 is 1. Okay, similarly for the index 3, which is also odd, So 3 plus 1, which is 4, by 2 is 2. Then for let's say 5 plus 1 is 6, 6 by 2 is 3. And let's say for another 7, and similarly for 9. So for 7, 7 plus 1, which is 8 by 2 is 4, and so on. Okay, so the logic for even indices is same, and just we are changing the logic for odd indices. We are saying a of I is equal to I plus 1 by 2. So if you run this code, what it will do at even indices, it will give the value of a must be 0, and then for odd indices, like it is 1, 3, 5 kind of thing. Okay, so let's analyze here. So for even indices like 0, 2, 4 and 6 and 8, you will find like 0. Okay, then for odd indices like for 1, 3, 5, 7 and 9, you can see like 1, 2, 3, 4 and 5. So what the question is like, the pattern should be like 0, 1, 2, 3, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Okay, so here you can analyze 0, 1, 0, 2, 0, 3, 0, 4 and 0, 5. And very simple. Now let me show you another question. What is another question is, how do you constrain an element of a dynamic array to be increasing order? Okay, very simple. Now what we is the question is like, write a constraint for increasing order, which means that if the value is 0, then next value should be 1, then 2, then 3, then 4 and then 5 kind of. Okay, so for that, multiple ways to ask. Like interviewer may ask you in these 3 different ways. How do you constrain an element of a dynamic array to be increasing order? One way. Another way, write a constraint in such a way that each element is greater than the one before it, or write a constraint for increasing order. Okay, so for this is the logic is also very simple. Let me show you. What we will do over here, we'll define a dynamic array of bit type and size is 3 down to 0. Okay, so 2 raised to power 4, 16 will be there values, and the size we are saying is 10. Okay, so a dot size is equal to 10, which means that the size of the dynamic array is 10 from 0 to 9. Okay, here we are using for each loop. So this for each loop will iterate over each element of the array using this index I, and we are saying if I is greater than 0, first we'll skip this first element, that is a of 0 will skip, because 0 minus 1, there is no no use of this 0. Okay, so what we'll do, we'll say inside the for each loop of a of I, we'll say if I is greater than 0, the index is greater than 0, then a of I must be greater than a of I minus 1, which means, let's say greater than 0 means the 1. Okay, so a of 1 is greater than a of 1 minus 1. 1 minus 1 is nothing but a 0. Okay, so 1 is greater than 0, then similarly 2 is greater than 1, then 3 is greater than 2 and so on. So you can see over here and analyze here in the comment I have given. So this is what a simple constraint for that, and then in the post randomization, just we are printing the values. The model definition is also simple. So if you run this code, you will see the increasing order value will be there. Okay, so let's say for example here the index is like 0, 1, 2, 3, 4 up to 9. Okay, because the size we are saying like 10. Okay, then the values you can analyze like 0, 2, 3, 4, 5, 6, 10, 12, 13 and 14. So this is like increasing order. Okay, now the assignment for you guys is write the constraint for the decreasing order. So here I have written a question for that. So the assignment for you people is to write a constraint for decreasing order. You can analyze this question and write. It is also very simple. The next question is like, how do you exclude a specific value from the randomization? Okay, this few other questions are there. We'll see this question in the next video. Okay, so another is like Fibonacci series, also interesting one. they will ask mostly in the interview. Okay, fine. So in the next video we'll see the remaining questions. Thanks all for watching this video. Thank you.